In the previous example, we have learned the equation for a curved surface when the light ray entering from a rarer medium to denser medium, and the curved surface which we have considered was a convex in nature. Okay, now for the same convex lens, we will do the derivation when the light ray enters from denser medium to rarer medium. We will see if there is any change. Okay, now our object is kept in the denser medium and we don't know where the image will be formed. Okay, so this is my object. Okay, this is the convex surface. Here I have the denser medium. So rarer medium is M1 and denser medium is M2, and I am going to mention the rarer medium with mu1 and this is mu2. Simply mu2 is greater than mu1, so that's the reason I have kept mu2 here and mu1 there. So always in my derivations I kept rarer medium as M1 and denser medium as M2. Okay, you can take the changes if you need. Okay, now we have an incident ray going from O, where I have kept my object, and one ray is going in this direction, which is undeviated, okay, along principal axis. Now next ray is going in this direction, so that would go in this direction. Now where is the normal? Normal would pass through the radius, so through the center of curvature. This is my normal. Now with respect to my normal, the angle made by incident ray is the incident angle I. Now we know whenever refraction occurs from denser to rarer medium, after refraction the refracted ray would go away from the normal. So this is my normal, so R should be greater than I. Now my R is greater than I and that is going away from my normal. So one ray is this from an object and second ray is going in this way. So we know that these two rays will never intersect, that will go in this direction, right? So we need an image. So where would be the image formed? So we can just extrapolate the line, we can extend the line to this direction so that it seems to us as intersecting at this point. So whenever we are watching from here with our eyes, we would see the object formed at here, this side, in the denser medium itself. So we have our object in the denser medium and also image in the denser medium. Okay, so object and image is in the denser medium and this is not real image. So real image would be formed only if when the rays are actually intersecting. So is this actually intersecting? No, this seems to be intersecting at this point. Actually they are not intersecting. So this is a virtual image at here because they are not intersecting. If they intersect in this way, actually these two rays are intersecting, then I can say that that is a real image, but here it is a virtual image. Okay, cool. Now we will try to get the equation here. We can apply Snell's law. So on applying Snell's law, sin I by sin R is equal to second medium divided by first medium. So this is the second medium, mu1, and this is my first medium, mu2. Now I have told you for small angle sin I is equal to I and that can also be equal to tan I. Okay. Now sin I by sin R. So sin I is equal to I itself. So sin I by sin R can be taken as I by R itself using this approximation is equal to mu1 divided by mu2. Cross multiply. I into mu2 is equal to R into mu1. An important relation this is. Now we need the equation for I and R. So we have learned even in the previous case the angle made by incident ray with respect to the principal axis is alpha, and angle made by the refracted ray with respect to principal axis is beta, and angle made by the normal with respect to the principal axis is gamma. So from this triangle, from triangle COP, I can say that alpha is equal to, this is the exterior angle and sum of interior angle, R plus I. First equation. Now similarly, from triangle, the bigger triangle CPI, from triangle CPI, I could say, so see, if this is R, the whole thing would also be R. Now these two are my interior angle, so R plus gamma is my interior angle, and the exterior angle representing that triangle is equal to beta. So this implies I is equal to alpha minus, okay, has we made any mistake? So this is not R, this is gamma. This one is R, okay. Now alpha is equal to gamma plus I, alpha is equal to gamma plus I from that triangle. Now from this triangle R plus gamma is equal to beta, okay. R plus gamma is equal to beta, okay. Now here this implies that R is equal to beta minus gamma. R is equal to beta minus gamma. In this case, I is equal to alpha minus gamma. An important relation. Okay. Once again, I'll repeat. Alpha is equal to I plus gamma, and I is equal to alpha minus gamma. And from the big triangle, R plus gamma is equal to beta, and R is equal to beta minus gamma. Okay, now here I is alpha minus gamma, right? So alpha minus gamma into mu 2 is equal to R. What is R? Beta minus gamma into mu 1. Cross multiply. So alpha into mu 2 minus gamma into mu 2 is equal to beta into mu 1 minus gamma into mu 1. Now bring gamma terms together. So gamma into mu 2 here minus gamma into mu 1. Bring this to here, alpha into mu 2 minus beta into mu 1. Alpha into mu 2 minus beta into mu 1. Minus gamma mu 2 went there with positive sign, and yeah, same. Now from here you can take gamma in common, mu 2 minus mu 1. Now I can take I as tan I. So similarly alpha as tan alpha. So tan alpha into mu 2 minus tan beta into mu 1 is equal to gamma is nothing but tan gamma into mu 2 minus mu 1. Okay. Now what is tan alpha? Tan alpha from this triangle, take the whole triangle OMP. Okay. In that tan alpha is equal to opposite by adjacent. So PM divided by OM. So PM divided by OM into mu 2 minus, what is tan beta? PM divided by IM. So PM divided by IM into mu 1 is equal to, what is tan gamma? Tan gamma is equal to PM divided by CM is equal to PM divided by CM into mu 2 minus mu 1. Okay, all PM can be cancelled. These are common terms. So now you can make the replacement. Mu 2 divided by, what is OM? OM is the object distance. Okay, so object distance is measured in this way. So that is minus U. Leftward length are negative, rightward length are positive. This is leftward measured length. Okay, so that is negative. Minus mu 1 divided by, what is IM? IM is nothing but image distance. So that is also measured in this direction. So minus V is equal to 1 by Cm. 1 by Cm, again that is a leftward taken length, and that is nothing but Cm is nothing but radius of the curvature. So that is minus R into mu2 minus mu1. So rearrange it. So this minus into minus will become plus. So that would be mu1 divided by V minus mu2 divided by U is equal to minus multiply there. So mu1 minus mu2 divided by R. This is the equation. Okay. Now, in the previous case, with the convex surface, with the curved surface having a convex nature, when the light ray entering from rarer medium to denser medium, we have seen an equation which was mu2 divided by V minus mu1 divided by U is equal to mu2 minus mu1 divided by R. And in that case, our object was kept in the medium mu1, that was rarer medium. See, this was the example. In the rarer medium we kept the object and the image is at the denser medium. So anyway, with U I have my rarer medium. Here with U I have my denser medium. The reason is I kept my object at the denser medium itself here. Or I can simply get the equation. If you know this equation, you don't actually need to derive this. Just replace mu2 with mu1. So if I am replacing mu2 with mu1, the equation would be instead of mu2 it would be mu1 by V minus of, now instead of mu2 it would be mu1 it would be mu2 divided by U is equal to mu2 would be mu1, so mu1 minus mu1 would be mu2 divided by R, which is this equation, simply this one. So if you know this equation, only learn this equation, you can easily get the equation when the light ray enters from denser to rarer medium in the curved surface by simply interchanging mu2 with mu1 and mu1 with mu2. So same equation, just interchange the value of mu1 and mu2, you can get the equation in both the case. Okay, now in the next video we will derive the expression for mirror, where we have a combination of both the cases. So we will have two curved surface, one from denser to rarer and again one more curved surface where it is again a refraction from denser to rarer. Sorry, in the first case, okay, we have a surface, a simple surface that is from rarer to denser. Now we will have one more surface where we have refraction from denser to rarer. Now from rarer to denser I have to apply this equation. From denser to rarer I have to apply this equation. So this would be a combination of these two and we can get the lens equation by doing certain operation with these two equations. Okay, thank you.